Hey everybody, why is the absolute value always in a good mood? Because they can never be negative. Oh yeah! It's time for math with Mr. Troy. Oh wait, math with the absolute value of Mr. Troy. Heyo! A slight programming note, I think that's the last joke of the lesson, but we'll see. Okay, so we need to move past how we do something and talk about why we do something. Okay? The absolute value of some number equals 10. If you were already taught how to do this, then you were probably taught one of two ways. What could I plug in and have the equation be true? The old guess and check method, tried and true. Two solutions, -10 and 10. Cool. Or, if depending on what Algebra 1 class you took, you may have done this sort of thing, split it up into a plus or minus. X equals -10 or x equals +10. Or maybe you even went to one of those fancy absolute value solving schools and you solved it like this. I'll teach you all of that. But first, what does it mean? Well, what it means is that some number has a size of 10. Some number has a size of 10. What number is 10 units away from 0? Well, either +10 or -10. So let's think back to the maybe middle school way of absolute value of what is that number's distance from 0. So that leads us to our next problem. What number has a distance of -10 from 0? Well, distance is defined as being non-negative. I wonder why. Non-negative distance has to be greater than or equal to 0. So there are no solutions to this equation. When you move on to the third equation, let's start by thinking about it the way that you would have thought about it if you were using the guess and check method. What could you put in here to make this equal 8? Well, 13 minus 5 would have to equal 8. But you could also make it -8. So if you did -3 minus 5, you'd get -8. And when you take the absolute value of those, you get +8. Okay? But we need to move past that way of thinking. We've got our 13 and we've got our -3. Let's think in terms of distance. If this means distance from 0, then what does this mean? I'll let you think on that. Now, I know some of you are just shouting the answers out to anyone around you at home, but let's see if we can motivate this a little better. Remember, this means the numbers on the number line who have a distance of 2 away from 0. Let's put that on the board. So what numbers are 2 units away from 0? Well, +2 and -2. Those are the two solutions to the above equation. And remember, because a quadratic and an absolute value are related, that plus or minus 2 does come from the same sort of place as a quadratic. Now, let's go back to the guess and check method for this. What are some numbers that I can plug in to make this equation true? So I think the more obvious answer is that 5 would work. 5 minus 3 is 2, and the absolute value of 2 is, in fact, 2. So let's put that on the board. 5 would work. Now the other one, if we did 1 minus 3, and then took the absolute value, that would be the absolute value of negative 2. And that does, in fact, equal 2. So the x value I used was 1. So how do these purple solutions relate to the original black solutions? I think it should be, I hope, fairly obvious. Crossing my fingers. So each of those solutions is moved 3 units to the right. So all of the sudden, we're not talking about centering around 0. We're talking about centering around 3. So what this means is all of the points that are a distance of 2 away from the number 3. Now, if you just want to solve an absolute value equation, here's what you're going to do. You're going to isolate the actual absolute value function. So you're going to get alone on the left side of the equation the absolute value of stuff. So we're going to subtract 2. And we're going to divide by negative 3. At this point, you want to check. You can read absolute value as distance. So does distance equal 6 make sense? Sure, 6 could be a distance. Does distance equal negative 7 make sense? No, distances can't be negative. So from here, you kind of have 2 different options, but the way that I do it is I split it up into the plus or minus. And I like to keep the stuff inside the absolute value the same. And I like to negate the other side of the equation. So in this case, it's a negative 6, and the positive version as well, the positive 6. If you had something longer here, you would negate the entire right side. So we're going to solve, and we're going to get x equals negative 7 halves, or x equals 5 halves. Okay, that's how we solve that. Feel free to pause the video and take your time with this if you've got questions about it. Remember, we can plug our answers back in just to make sure. So if we plug this negative 7 halves back in, we're going to get negative 3 times the absolute value of negative 6 plus 2 equals negative 16. Now the reason it's okay to have a negative 16 here is because this can still turn into a negative number. Does negative 18 plus 2 equal negative 16? Sure does. And it would work exactly the same way for 5 halves. We'd get the same sort of thing. The only difference here is that when we check, we would have a positive 6 inside the absolute value. When we've got something a little bit more complicated, we just have to be careful in one aspect, okay? So that one aspect is when we split and we take our plus or minus, the stuff inside the absolute value, the argument of the absolute value function, is going to be the same on both sides. On one side of the equation, we're going to negate the entire right side of the equation. And on the other side, we are going to keep the entire right side of the equation. This is the same thing as multiplying times -1 and times +1 on the right side of the equation. So in this case, we're going to get two quadratics. X squared minus 3x equals 4x minus 6. And x squared minus 3x equals -4x plus 6. We're going to go ahead and solve those. Remember, most quadratics have two solutions, either real or imaginary. We're only concerned about real numbers when it comes to solving these. But you're going to be on the lookout, you think for as many as 4 solutions. So for example, I'm going to get x squared minus 7x plus 6 equals 0. And x squared plus x minus 6 equals 0. Let's go ahead and solve those. Okay, I got 4 solutions, but anytime an equation has a domain restriction or a range restriction, I need to be careful and I need to check all of my solutions because sometimes they don't work. Let me give you a quick example here. If I plug in 6 to both sides of the equation, so I'm going to check 6 first, I'm going to get 36 minus 18 inside an absolute value equals -24 plus 6. Or this simplifies down to the distance equals a negative number. So that is an extraneous solution. It means it does not work. So when that happens, we cross it out. That solution does not work. So at this point, pause the video and see if you can figure out which solutions do work and which solutions don't work, and the answer will come in just a few seconds. I mean, really, as long as you pause for, that's when the answer will come. All right, ready? 3, 2, 1, pause. Okay, 1 and -3 work, but 2 does not work. And we can actually figure that out without even having to do anything to the left side of the original equation. So we can just say the absolute value of stuff, very technical mathematical term, equals -8 plus 6. Well, we know that the absolute value of stuff cannot be -2. This is impossible. So because of the range of the absolute value function is from 0 to infinity, -2 doesn't work for that. All right. Folks, make sure you practice up on this because this is the easier part of this particular subject. I know that you will master it. It's fun. It's easier. But as long as you keep working on it, you will be fine. All right, cool. Bye.